Hi, this is Abhilash Nelson and I am thrilled to introduce you to my new course, Deep Learning and Neural Network using Python for Dummies. The world has been revolving much around the term machine learning and deep learning recently. With or without our knowledge, every day we are using these technologies. But a big problem is that when you think about learning these technologies, a common misconception that lot of maths and statistics need to be studied prior to learning the artificial intelligence technologies. It's just like someone tries to make you believe that you should learn the working of an internal combustion engine before you learn how to drive a car. The fact is that to drive a car, we just only need to know how to use the user-friendly control pedals extending from engine, and with a bit of experience you can easily be an expert in driving a car. Just like that, in our deep learning course we have a perfect balance between learning the basic concepts along with the implementation, the practical implementation. Let's now see how this course is organized and an overview about the list of topics included. We will be starting with few theory sessions in which we will see the overview about the deep learning and neural network, the history of neural networks, the basic workflow of deep learning, biological and artificial neurons, and also the various applications of neural network will be covered in this session. And in the next session, we will try to answer the most popular yet confusing question whether we have to choose deep learning or machine learning for an upcoming artificial intelligence project. And after all these theory sessions, we will go ahead with preparing our computer. We will install Python environment for doing the deep learning coding, and we will install Anaconda, which is a platform in which we are going to do the Python code to proceed with our exercises. And once we have our computer ready, we will learn the basics of Python programming language, which could help us if you are new to Python and to get familiar with the basic syntax of Python. We will cover the basics like the details about Python assignments, flow control, functions, data structures, etc. And later we will install the libraries for our project like Theano, TensorFlow and Keras, which are the best and the most popular deep learning libraries. We will try a sample program with each libraries to make sure it's working fine and also learn how to switch between these libraries. Then we will have another theory session in which we will learn the concept of multi-layer perceptrons, which is the basic element, the building block of deep learning neural network, and the terminology and major steps associated with training and building a neural network. And after all these exhaustive concepts and theories, we will move on to real-world deep learning models. And at first, we will download and use the Pima Indian onset of diabetic dataset. We will build a classification model and then we will train the model using this dataset. Then we will evaluate the accuracy of the model. We will also try manual and automatic data splitting and also k-fold cross-validation technique in order to validate the accuracy of this model. The next interesting dataset that we are going to use is the iris flower classification dataset. This dataset is called as a multi-class dataset. We will build a multi-classification model with this dataset and we will train the model and try to evaluate the accuracy using the techniques that we discussed before. For the next model, the next dataset we are using is the Sonar returns dataset. This dataset contains the data about strength of sonar signals and the classification whether it was reflected from a rock or any metal. We will build the base model and then we will evaluate the accuracy. Also, we will try to improve the performance of the model with data preparation techniques like standardization and also by changing the topology of the neural network. For the next exercise, we will be using the Boston House Prices dataset. This is a regression dataset. For this one also, we will be building the model and we will try to improve the performance of the model with data preparation techniques like standardization and also changing the topology of the neural network. And from these projects you will come to know that we are spending our valuable time designing and training the model. So we will see how we can save the already trained designed and trained model structure to either a JSON or YAML file, and along with the weight as an HDF5 file. And later we will load these saved files and convert it back to a live trained model. We will try this for all the projects and all the dataset that we have learned so far. And now the most awaited magic of deep learning is going to happen. Our genius multi-layer perceptron models will make predictions for the custom input data that we are inputting into the system. The Pima Indian model will predict whether I will get diabetic in future by analyzing my actual health statistics. And in the next model, the iris flower model, it will predict the correct species of the newly blossomed iris flower in my garden. Also, the prediction will be done with the Sonar returns model to check if the data provided, the data we just provided, matches either a mine or a rock under the sea. And then with our next multi-layer perceptron model, the regression model, the Boston house pricing model, we will predict the median value of the cost of housing in Boston. Large deep learning models may take days or even weeks to complete the training. We have a feature called checkpointing. We can safely mark checkpoints and keep them safe, then load a model from that particular point at a later time. Checkpointing can be done based on every improvement to a model during training or the best instance of the model during training. At times, we may need to supervise and take a look at how the model is doing while it's getting trained. We can access the model's training history in Keras very easily, and if needed, we can visualize the progress using a graphical representation. Then we are going to deal with a major problem in deep learning, which is called as overfitting. It's been troubling the deep learning engineers since deep learning was introduced. We will learn how to include dropout regularization technique, which can prevent this overfitting problem. We will try to include this regularization to both visible as well as the hidden layers. And using Keras, we can control the learning rate of a model. Time-based as well as drop-based learning rate schedulers. We will be using a dataset called the ionosphere classification model to demonstrate this learning rate controlling feature. And that's all with multi-layer perceptrons. And in the sessions to follow, we will learn a powerful deep learning neural network technique called as a convolutional neural network, or CNNs. And during the CNN sessions, at first we will have an overview about the convolutional neural network and how it works, its architecture, and then we will proceed with some popular and interesting experiments with convolutional neural network. The major capability of deep learning techniques is the object recognition in image data. We will build a convolutional neural network model in Keras to recognize the handwritten digits. We will use the openly available MNIST dataset for this purpose. We will at first build a multi-layer perceptron based neural network, and later we will upgrade that to a convolutional neural network. And you know what? We are bold enough to do prediction with a handwritten digit using our MNIST dataset. We will take time to train the model, then save it, and later we will load it and do quick prediction with the already saved and trained model, just like how it's done by a professional deep learning engineer. We will then later try to improve the performance of this CNN model by making the network a bit larger. We will also try techniques like image augmentation, sample standardization, ZCA whitening, transformations like random rotations, random shifts and flips to our already augmented images, and we will finally save this augmented images as the next dataset for our later use. And then we will go ahead with another important and challenging project using CNN, which is the object recognition in photographs. We will use another openly available dataset called the CIFIR10. We will learn about this CIFIR10 object recognition dataset. We will at first create a simple convolutional neural network for object recognition. One more time, we will have the guts to do a real-time prediction with the CIFIR10 dataset. the convolutional neural network model, where the model will identify a cat and a dog from the image that we supplied to the system. And the code and other resources that we use for all these exercises and projects will be attached as a single zip file along with the resource section of the video, so that you can download it and use it or keep it as reference for your later projects. Overall, this is a basic to advanced crash course in deep learning neural network and also convolutional neural networks using Keras library in Python programming language. And I'm sure that once you complete this course, you will skyrocket your current career prospects, as this is the most wanted skill nowadays, and of course this is a technology of the future. We will also be providing you with certificate after the completion of this course, so that you can use it as a proof of your expertise and you can attach it with your current portfolio. We don't have to wait long. There is a day in the near future itself when the deep learning models will outperform human intelligence. So be ready and let's dive into the world of thinking machines. So best wishes with your learning. See you soon in the classroom. Bye bye.